Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Understanding client-side hardware and software requirements is critical when preparing a system to run modern operating systems or applications. These requirements determine whether a given device has the capacity to support installation, operation, and future updates. The A+ exam focuses on a clear distinction between minimum and recommended specifications, which often differ significantly in terms of performance and reliability. These include core hardware components such as the processor, memory, and storage, as well as software and security configurations required for successful deployment and optimal functionality. Central processing unit specifications are a fundamental part of evaluating compatibility. Clock speed, measured in gigahertz, and the number of cores directly affect how fast a system can execute tasks and support multitasking. In addition, many applications specify instruction set compatibility, such as requiring a 64-bit processor. Some advanced features, including virtualization and certain types of encryption, depend on processor-level support. Without these capabilities, applications may fail to install or run inefficiently, and some features might be entirely unavailable to the user. Memory requirements play a key role in software performance. While the minimum amount of RAM allows an application to launch, it may not provide the smooth or responsive experience users expect. The recommended amount of memory is generally much higher and accounts for background tasks, operating system overhead, and multitasking scenarios. Additionally, systems using 32-bit operating systems have a memory ceiling of approximately 4 GB, which can limit performance significantly when compared to 64-bit systems that support far more RAM and are better suited for modern workloads. Storage specifications are another critical factor, especially when planning software installations or updates. Requirements include the total install size, space for temporary files, and additional room for logs, cache, and future patches. While traditional hard drives are still supported, solid-state drives offer a substantial performance boost and can reduce application load times even on low-powered devices. Ensuring there is sufficient free space also supports system stability and prevents update failures due to lack of disk capacity. Graphical requirements may also need to be considered, particularly for applications that depend on real-time rendering or complex visual effects. These programs may require a dedicated graphics processing unit, or GPU, especially in scenarios involving media editing, design, or simulation. Minimum DirectX or OpenGL versions are often listed in the application's technical specifications, and some programs will not function at all if hardware acceleration is not available. Integrated graphics may suffice for basic tasks, but more demanding tools typically perform poorly without specialized GPU support. Operating system compatibility is essential to verify before attempting any installation. The OS must support required drivers, libraries, and application programming interfaces used by the software. This often means ensuring the system is fully updated with the latest service packs or patches. Some applications limit compatibility to specific OS editions, such as professional or enterprise versions, and will block installation on unsupported versions. Keeping the OS current also improves overall security and stability, which are necessary for running modern software reliably. Browser and plugin requirements are especially relevant for cloud-based applications and platforms. Many tools specify which browsers they support and may function incorrectly or not at all on unsupported versions. Legacy plugins like Java or Flash may be required in some legacy systems, though many modern applications have phased them out due to security concerns. The presence of browser extensions or security settings can also affect compatibility, potentially blocking scripts, pop-ups, or necessary resources required for the application to function properly. Security software can also impact the installation and operation of applications. Antivirus programs, endpoint protection suites, and firewalls may flag new software as suspicious or block components during installation. Some applications include built-in integrity checks and will halt installation if they detect threats or conflicting software. Additionally, Endpoint protection software must be configured to allow the application's network traffic and background processes to run uninterrupted. Failure to adjust these settings can result in partial functionality or complete launch failure. System privileges and access controls must also be considered. Many installations require local administrator rights to access protected areas of the file system or registry. Without these permissions, installation may fail, or features within the application may not function correctly. User account control prompts may appear during the install process, requiring manual elevation of privileges. If the application is denied access to critical directories or settings, it may crash, behave unpredictably, or refuse to run altogether. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Network connectivity is an essential component of many modern applications, especially those that rely on cloud-based functionality or real-time data exchange. Some applications require constant internet access to function, while others may operate offline but periodically check for updates or validate licenses. Virtual private networks, proxies, and strict firewall rules can affect how these applications connect to required services. Understanding the bandwidth needs of a program is also important, as software that performs streaming, synchronization, or remote access may demand higher throughput than casual browsing or document editing. Firewall configuration and port accessibility are often overlooked but can cause major issues during application setup or runtime. For many programs to operate correctly, firewalls must allow both inbound and outbound traffic on specific ports. Some services rely on dynamically assigned ports or complex communication protocols, requiring custom firewall rules. If a firewall is misconfigured, it may silently block parts of the application, leading to partial functionality or connection errors. Examining which ports are used and ensuring proper exceptions are in place is critical during deployment and troubleshooting. Applications licensed through enterprise volume agreements often depend on internal servers or domain infrastructure for validation. These systems may require that client machines be part of an Active Directory domain and have consistent network access to the licensing server. Issues such as incorrect domain membership, DNS resolution problems, or time synchronization errors can cause license checks to fail. Without proper validation, applications may enter reduced functionality modes, display activation errors, or become completely unusable after a grace period. Keeping the operating system and applications up to date is another vital aspect of compatibility. Many programs depend on specific patches or system libraries that are only available through updates. If the host system is missing critical updates, the application may crash, display rendering issues, or lack access to core features. Some software includes built-in update checkers that prevent execution until the latest patches are applied. Verifying that automatic updates are enabled and functioning helps maintain a secure and compatible environment. Runtime dependencies are another technical consideration that can block installations or impair functionality. Programs developed in certain environments may require the .NET Framework, Java Runtime Environment, or Visual C++ redistributables to be present on the system. If these components are missing or outdated, the application may fail to install or generate errors upon launch. In structured deployment processes, it is best practice to install all required runtimes before introducing the main application, either manually or through automation scripts. Performing system backups before making significant changes is a recommended precaution. Whether deploying a new application, upgrading the operating system, or modifying existing configurations, a backup provides a safety net in case of incompatibility or failure. Backups ensure that system states can be rolled back without data loss, minimizing downtime and recovery costs. In some environments, backup policies are mandatory and may dictate the timing, method, and storage location for all backup data. Exam questions often involve analyzing whether a given system meets specific hardware or software requirements. You may be asked to determine if a laptop has enough RAM to support a new operating system or whether a legacy CPU lacks necessary instruction sets. Other questions might require matching system specifications with software checklists or identifying why a program fails to install. The ability to diagnose compatibility issues based on requirement gaps is an essential skill in both the exam and real-world support scenarios. Monitoring system resources is a practical way to evaluate how well an application is performing on a given machine. Tools such as Task Manager and Resource Monitor in Windows display real-time data about CPU usage, memory consumption, disk activity, and network throughput. These tools can help identify whether a system is under strain or if specific processes are using an unusually high level of resources. Monitoring performance is also useful when diagnosing compatibility issues that may not trigger error messages but still cause slowdowns or instability. Virtualization compatibility is another factor to consider, especially in environments that use virtual machines for testing, training, or deployment. The client device must support virtualization features such as Intel VTX or AMD, which are often disabled by default in BIOS or UEFI settings. Without these features, the system may not be able to run hypervisors like Hyper-V or VirtualBox. Ensuring that virtualization is supported and enabled is crucial in labs, sandbox environments, and remote access scenarios that depend on virtual desktops. In conclusion, careful planning around client-side requirements helps ensure that software and operating systems install properly and function as intended. Factors such as processor architecture, available memory, storage type, operating system version, and security software must be aligned with application demands. Network settings, firewall rules, licensing servers, and runtime dependencies must also be taken into account. Understanding these requirements allows support professionals to prevent deployment failures, reduce help desk calls, and maintain consistent user experiences in both personal and enterprise environments. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.